some more interesting and important questions from Karnataka CET questions. Come on, let us discuss the first question. 5.5 milligram of nitrogen gas dissolves in 180 gram of water at 273 Kelvin and 1 atmospheric pressure due to nitrogen gas. The mole fraction of nitrogen in 180 gram of water at 5 atmospheric pressure, nitrogen pressure is approximately how much? This is like one, they have given a complete data. The other one, they are asking that data. See, that is like 10 apples equal to this much, one apple cost, like that is the way. Okay, now here, one more point I would like to mention here. Henry's law, they are bringing, what is it? Henry's law, partial pressure. So here, partial pressure is directly proportional to mole fraction of the ideal gas, right? So in this point here, 5.5 milligram of nitrogen, come on, I just mentioned the data so that it will come to know very clearly. 5.5 milligram of nitrogen gas dissolves in 180 gram of water at 273 Kelvin. Okay, so 273 Kelvin temperature also they have provided, 1 atmospheric pressure. Okay, 1 atmospheric pressure. So this is the first data. So 5.5 milligram of nitrogen dissolves in 180 gram of water, temperature 273 Kelvin and 1 atmospheric pressure. Now here the mole fraction of nitrogen in 180 gram of water at what it is, 5 atmospheric pressure. Nitrogen pressure is how much? That is what they are asking. Okay, come on, how do we go for it? So number of moles we have to identify, because given mass they have provided, no, so number of moles, so number of moles of nitrogen gas. So nitrogen gas, how to identify? So given mass by molecular mass. So given mass, what it is, 5.5 milligram. So we can convert it into gram, because molecular mass it will be there in gram, right? So that is what. So 5.5 into 10 to the power of minus 3 gram, because it is milligram, no, so that is what I just mentioned, 10 to the power of minus 3 gram divided by nitrogen. What is the molecular mass? It is 28, right? So 28 gram per mole. So this gram and this gram will be cancelled. So what is the answer you will be getting? You'll be getting around 1.964 into 10 to the power of minus 4, 10 to the power of minus 4 mole you'll be getting, right? So this is the answer for number of moles of nitrogen gas. Right. Okay. Now, number of moles of water, because mole fraction only they are bringing. No, so mole fraction is what it is, N1 and N2. So this is N1, we got it. N2, what it is, number of moles of water. So number of moles of water. So how much it is? So that is here also 180 gram they mentioned. No, so 180 gram means here 180 gram divided by 18. No, what a molecular mass of water? It is 18. So 18 gram per mole. So this gram and this gram will be cancelled. So what is it? 10 mole. So we got both the ideas of moles. So now we are going to check mole fraction. So how do we identify the mole fraction? So mole fraction equal to mole fraction. This is a capital chi. Okay, so chi of nitrogen gas N2 equal to N of N2 divided by N of water molecule. So equal to how much it is? 1.964 into 10 to the power of minus 4 divided by 10. Right. Okay. So this is 10 mole and this is both. We are dividing. So how much we are getting? So mole fraction, how much it is mole fraction? So mole fraction is how much it is? 1.964 into 10 to the power of minus 5. Okay. Now we got that initial mole fraction, because they have given the idea about initial. Now we are going to see that final, like what it is. First idea we got it. Now from this we are going to get the second idea. Okay. Now the mole fraction of what it is, nitrogen gas, we got it. Okay. Now I just mentioned here chi of chi. We can mention chi 1 and chi 2, right? So chi 1 initial mole fraction, initial mole fraction nitrogen gas equal to 1.964 into 10 to the power of minus 5. So that is no unit for mole fraction. And the same way partial pressure P1, I just mentioned P1 initial pressure of nitrogen, how much it is? 1 atmospheric pressure. So this is the first idea. 5.5 milligram of water dissolves in 180 gram of water, so and so 1 atmospheric pressure. So this is initial mole fraction, we got it. Now we are going to see what it is, a new mole fraction. That means a final mole fraction also we can say, or new mole fraction, that is chi 2 we can take. Chi 2, what it is, that is a 5 atmospheric pressure they have given. No, that is what we are going to see. So I just mentioned new mole fraction. So new mole fraction N2, that is what the question. Okay, now here what it is, partial pressure. So P2, new partial pressure, new pressure. How much it is? Pressure of nitrogen gas only we are going to check it. How much it is? 5 atmospheric pressure, right? So in the question only very clearly. So this is what we have to check it. Now this is actually what is the formula here. Chi1, that is mole fraction 1 divided by partial pressure 1, that is new, what it is, initial, equal to chi of 2, that is new mole fraction divided by partial pressure 2. So this is the formula. We are going to apply this value. So all these values what we have provided here, no, so that just we are applying. Now chi2, that is x2, we are bringing out. So that means what is the formula? You can bring it over here. So chi1 into P2, that is partial pressure 2, that is new partial pressure divided by new what it is, initial P1. Okay, so this is the way you can apply the value. Okay, hope you got the clarity. Now this is chi2 only. No, so chi2 means what is it? Chi2 is equal to chi1, what it is, 1.964 into 10 to the power of minus 5 into 5 atmospheric pressure divided by 1 atmospheric pressure. So what is the answer you will be getting? You'll be getting around 9.82 into 10 to the power of minus 5. So this is what it is, mole fraction of new nitrogen gas, that is at 5 atmospheric pressure. How much? That is what mole fraction they are asking, right? So a complete idea I have given this data. So which is the correct option? 1 point, what is the answer? 1 into 10 to the power of minus 5. So here, what is the answer we observed? Here actually 9.8. What it is, 9.82 into 10 to the power of minus 5. So we just approximately bring the answer. What is that they have provided? 1 into 10 to the power of minus 5, approximately, right? In the question, in the options they have given this only. So approximately, which is the correct option? 1 into 10 to the power of minus 5. And 9.8, it's more or less 9.8 into 10 to the power of minus 5. 9.8, it is more or less 1 now, going to be 1. So that is what. Okay, so 1 into 10 to the power of minus 5. So option B as the correct option. Hope you got the clarity. How do we go for it? So first point, they will find that what it is, concept. Then we can apply the data according to this. Hope you got the clarity. Come on, let's go to the next question. Centimeter cube of 0.04 m K2Cr2O7 in acidic medium oxidizes a sample of H2S gas to sulfur. Volume of 0.03 m KMnO4 required to oxidize the same amount of H2S gas to sulfur in acidic medium. See, this question they are asking about indirectly how many electrons loses for each point they are asking, right? So in that way, let us write the data so that you'll come to know the clarity. So K2Cr2O7 plus H2. Yes, so it gives actually, yes, that is sulfur. Yes. Okay, so here what they are mentioning, this is X actually, same amount of volume product. Okay, same amount of product. I just mentioned the data, then we can discuss product. Right now, and that another one, volume of 0.03 of KMnO4 required to oxidize the same amount of H2S gas to sulfur in acidic medium. So here also the same. So here also what it is, KMnO4. So KMnO4. So this is K2Cr2O7 and this is KMnO4 plus same H2S gas required. Here also sulfur X amount. Okay, same amount of product. Okay, now here actually here M1, we just bring it M1 equal to 0.04 m molarity, and V1 volume, how much they have given, it is 50 centimeter cube, right? You got it. And next one what they are asking here, M2, we just take it as a M2. Here what it is, 0.03 m molarity, V2. I hope you go B2 only we have to identify. I think you got that clarity. See here 50 centimeter cube of 0.04 m K2Cr2O7. So this molarity they have given in V1. So this is M1 and this is V1. And the same way, this is M2 and V2 what it is. So the same amount of H2 gas. So here what it is, how much it is required to oxidize. That is what the question. So M1 we got it. M1 it is there and V1 it is there. And the same way, M2 it is there, V2 we have to identify. For this data we got it. Now how do we go to analyze that point? Means here electrons are losing or gaining, in that way we have to identify. So K2Cr2O7, how many electrons lost? So factor, because how many electrons lost or gained for each, let us identify. In this point K2Cr2O7, here this is minus 14, right? Minus 14 and this is plus 1, so you are getting 2 atoms, so this is plus 2. So that means here what you will get it, you will get plus 6. Okay, oxidation state plus 6. Okay, now equivalent mass we have to identify. So what is the equivalent mass of K2Cr2O7? Equivalent mass equal to molecular mass divided by on n factor. So n factor means number of electrons lost or gain in that. Okay, so here molecular mass of K2Cr2O7, this is 2 94.185 divided by here n factor plus 6. So how much you will be getting? 49. Equivalent mass, it is 49 of K2 Cr2O7. So please remember this point. This is what it is, gram per equivalent mass. That is, right now KMNO4, let us check KMNO4. So KMNO4, how do we identify? Here also, this is minus 2, no? So this is minus 8. This is plus 1. So you will get what it is? Plus 7, right? Plus 7 oxidation state. And the same way, molecular mass by n factor. So molecular mass of KMNO4, it is 158 divided by plus 7, right? So you will get what it is? 22.5. So this is equivalent mass of KMNO4, right? Now we are going to give the idea. Here it is some molecular mass divided by equivalent mass into molarity. So this is the formula we are going to apply to get the answer. Now in this molecular mass of K2Cr2O7. So K2Cr2O7, how much it is? 294.185 divided by equivalent mass of K2Cr2O7, 49, right? So 49 only we got there. So 49 into here what it is? Here 0.04. First molarity, K2Cr2O7 molarity 0.04. So this is gram per mole, right? So what is the answer? When you calculate this, you will get the answer here around 0.24. 0.24 n normality. So this is actually normality. So how to identify normality? Molecular mass by equivalent mass into molarity. So that is normality, right? Okay, and the same way, I hope you got the clarity about this point. And the same way here, what it is? KMNO4. So KMNO4 of what it is? Normality. Right? I hope you are getting that idea. How do we go for it? So this is 158, that is gram per mole. Whose gram per, what it is? Molarity, molecular mass. It is KMNO4 molecular mass divided by equivalent mass. It is 22.5, right? 22.5, right? Into what is that molarity here we have observed? Here actually what it is? 0.03, right? 0.03. So you will get around, what is the answer you will be getting? 0.15 normality of KMNO4. Okay, now let us check this formula. N1V1 equal to N2V2. So this formula only we are using. So here N1V1 equal to N2V2. Okay, now here and this, I just to bring all the data, 0.04 K2Cr2O7 equal to 0.24 N, that is normality of K2Cr2O7, right? And the same way here what it is? 0.03 Km, that is M, right? This is also M, molarity, KMNO4 equal to here 0.15 N. This is what it is, KMNO4, right? Now how do we identify here? This is what it is, N1V1 equal to N2V2. I just bring it here, no? So here V2 we did not know. So this is actually V2 only we have to identify, no? So here N1V1, N2V2. In that way, here V2 equal to N1V1 by N2, right? N2, right? So that means let us apply 0.24 into 50 ml, that is volume, divided by 0.15, that is this point. Okay, now here when we calculate this, you will get around 80. So what is it? V2, it is volume, it is 80 ml, right? I hope you got the clarity how to identify. This is going around the neck only. M1 V1, M2 V2. M1 it is for molarity. So from that molarity that they are asking about oxidizers. So oxidizers means we have to identify number of electrons. So number of electrons, that is n factor. So when we are going for number of electrons losses or gaining, we have to go for that normality. In that normality, what it is? Equivalent mass we have to identify. So it is going around the neck, but I hope you got that idea. How do we go for it? If you write that what it is, data, it will be easy for us to identify the answer. Come on, what is the answer? It is 80 ml, 80 centimeter cube. Yes, we got it. Option B is the correct option. Option B. I hope you got the clarity. How do we go for it? Yeah, come on, let's go to the next question. 0.06 percentage W by V, that is mass by volume, weight by volume aqueous solution of urea is isotonic with they have given the options. See, isotonic, first and foremost, we have to identify this is a concept. Isotonic means same concentration as another solution. Isotonic means same concentration as another solution. Right. So isotonic, it is nothing, same concentration. So same concentration, what is it concentration in that same concentration glucose solution? See, everywhere they mention glucose solution only. So here aqueous solution of urea concentration is equivalent to glucose solution. So now here glucose, here before that glucose, here urea. So urea, what it is? NH2CO NH2. So this is the formula of urea, right? Urea. Right now here in this point molarity, we have to check it. Why? Because they have given what it is, weight by volume. So weight by volume is what it is, percentage wise they have given 0.06 percentage. Right here 0.06 percentage of aqueous solution of urea. Right, urea. Right, so in that molarity is equal to what it is, molarity. So molarity equal to number of moles of solute, number of moles of solute divided by volume of solution in liter. Right, so this is what molarity. Okay, now in that number of moles we have to identify. So number of moles equal to what it is, number of moles equal to given mass by molecular mass. Right, so given mass, what it is here, what 6 0. What it is, given mass equal to 0.06 percentage they have given. So percentage, how do we remove that? Here 0.06 divided by 100, can we write it? Okay, so 0.06 divided by 100. Okay, can we apply the molarity value? So here what it is, 0.06 divided by molecular mass, how much here, molecular mass of urea NH2 CONH2. So this is molecular mass 60 gram per mole. You check it. Okay, so 60 into 1000 divided by this 100, we bring it here. Right, so this is 0.06 divided by 100. No, I just put it in this way. Okay, now let us check what is the answer. When you calculate this, you will get 0.01. Right, so 0.01. So 0.01 m molarity. So the answer, it is 0.01. That means the same concentration of another solution. That is what starting only I just bring it that idea about what it is. Isotonic means what it is, same concentration as another solution. That is what glucose, everywhere they mention glucose. Right, so glucose, everywhere they mention glucose. That means you isotonic, it is nothing, same concentration as another solution. So that means 0.01 is the correct option. 0.01 option C is the correct option. That is what the same. Right, hope you got the clarity about this question. Come on, let's go to the next question. See, this is a concept. If you are identifying the concept, you can solve any number of questions related to value may be changed, but concept it is same. Okay, yeah, come on, let's go to the next question. 3 gram of an organic compound containing carbon, hydrogen and oxygen on combustion yield 0.44 gram of carbon dioxide and 0.18 gram of water. If 1 mole of a compound weighs 60, then molecular mass, molecular formula of the compound. See, this is empirical formula idea only. Come on, let us identify. So this is carbon, this is carbon, hydrogen, oxygen. This is organic compound, right? Organic compound. During combustion, it gives carbon dioxide, of course, water. Any organic compound while combustion time, you will get carbon dioxide and water only. So the data they have provided, 0.30 gram of organic compound while combustion time, you are getting 0.44 gram of carbon dioxide and 0.18 gram of water. Yes, now if 1 mole of compound weighs 60, what is the molecular mass? So now we have to identify the given mass they have provided. No, so let us identify the number of moles and then we can get the mass of carbon and hydrogen. Then we can identify what it is, molecular formula. Right, now here what it is, number of moles of carbon dioxide, because from that product only we can go. So here what it is, given mass by molecular mass. So that is 0.44 gram divided by 44 gram per mole. So what is the answer you will be getting? 0.01 mole you will be getting. Right, this gram and gram will be cancelled, this 0.01. Okay, now here in this point, mass of carbon I wanted to bring. So mass of carbon equal to, here actually what it is, number of moles into atomic mass of carbon. How much it is? Number of moles is 0.01 into 12 gram per mole. Right, so how much you'll be getting here? 0.12 gram of mass of carbon related to this topic, this point. Okay, and the same way, number of moles of water, number of moles of water, how much? Given mass by molecular mass. So 0.18 gram of water divided by molecular mass, 18 gram per mole. So you will get what it is. Yeah, in this I wanted to mention one more point here. water, it is actually number of moles of hydrogen, 2 hydrogen is available. Here actually 1 mole of hydrogen only, number of moles of hydrogen, 1 only. So that means here 2 directly we can put it 2 over here. So that means here what is the answer you'll be getting? 0.02 mole you'll be getting. Why I put it 2 over here? I hope you got the clarity. This 2, this is actually 1 mole. That means 1 mole of hydrogen, it is a half mole of water in that way. So here 2 hydrogen knows that automatically here 2 I just mentioned. So in this point here, mass of hydrogen also I just bring here. So mass of hydrogen. So here mass of carbon knows the same way mass of hydrogen. So mass of hydrogen 0. That is number of moles into atomic mass of hydrogen, 0.02 into 1 atomic mass of hydrogen. So you will get the same 0.02 gram only mass of hydrogen. You will get mass of carbon also. Now mass of oxygen you have to identify, because here carbon, hydrogen, oxygen, no, combined together. So that is what. So here carbon, hydrogen and oxygen. So organic compound, organic compound is equal to here mass of carbon plus mass of hydrogen plus mass of oxygen, right? So mass of oxygen we have to identify. So here what is the data we brought it here? 0.12 gram of carbon plus 0.02 gram of hydrogen. Yes, we got it. No, this, that is what purposely I brought that idea. Okay, now so plus oxygen we don't know, so oxygen we have to identify. So organic compound, how much they have given? 0.30, right? 0.30 gram. So this one we got it. Mass of carbon we got it, mass of hydrogen we got it. So mass of oxygen we just bring it. So mass of oxygen, right? So mass of oxygen, that is 0.03 minus, here both we can calculate. So these both if we calculate, it is 0.14, right? 14. Okay, so 0.14. So if we calculate this, if you reduce this 30 minus 14, it is 0.16 gram of oxygen. I hope you got the clarity, right? So the same way, number of moles, right? So this is given mass, like, okay, number of moles of oxygen. So oxygen, it is O2, right? So that is O. Here given mass, it is actually 0.16 divided by atomic mass here, molecular mass, no, 16. So you will get what it is, 0. Here atomic mass only 0.01 mole only, right? This is gram per mole always, gram, right? Okay, now we got all that. So molar ratio, what it is? So molar ratio, right, so molar ratio, carbon, hydrogen, oxygen. So here molar ratio, it is actually 0.01, here 0.01, here 0.02. That is what they mentioned, right? Yes. Now that means this is 1 is to ratio, right? 1 is to 2 is to 1. So here empirical formula we can bring. So empirical formula. So this is carbon, hydrogen, oxygen, right? So carbon, hydrogen, oxygen. So carbon 1, hydrogen 2, oxygen 1. So empirical formula, what is the mass of empirical formula here? Carbon 12, hydrogen 2, oxygen how much? 16. So altogether it is 30. So N equal to what it is? Molecular mass by empirical mass. So N equal to molecular mass by empirical mass. So molecular mass, it is actually, they have mentioned 60, no? 60 divided by 30. So you will get 2. So here what you will bring it? CH2O into 2 whole. So you will get C2H4O2. So this is the molecular formula, right? So molecular formula, molecular mass they have provided, right? So let us check if this is correct or not. So this is 12 plus 12 plus 4 and plus 32, right? This is 24 plus 4 plus 32, right? How much it is? 28, 32. So this is 0, this is 5, 6, 60. 60 only they have mentioned, if 1 mole of a compound weighs 60, so that means molecular formula. So molecular formula, what it is? C2H4O2. Yes, C2H4O2. See, now how do we bring it? Easy way and interesting also. If we know the concept, easily you can identify the answer if you have logical way of thinking. So C2, what it is? Yeah, C2H4O2 is the correct option. Option D is the correct option. C2H4O2 is the correct option. Base, it is 16. So indirectly also you can find, but it will be same only around, I think so. Yeah, come on. I hope you got the clarity. How do we identify? Yeah, come on, let's go to the next question. Amount of dioxygen in grams contain 1.8 into 10 to the power of 22 molecules. See, each and every time one or the other way they will ask such kind of questions. See, actually, what is the data? Oxygen, O2, dioxygen, it is in grams. Actually, what amount of dioxygen in grams contain? 1.8 into 10 to the power of 22 molecules. They are asking the gram given mass. Like, okay, now here, what is the data they have provided? 1.8 into 10 to the power of 22 molecules. Molecules, right? So that means here it is very easy. So number of moles, you just go for it. Number of moles. So number of moles equal to give number of moles of oxygen. This is actually what it is given data, that is 1.8 into 10 to the power of 22 molecules divided by Avogadro number for one atomic oxygen, right? So 6.023 into 10 to the power of 23. So how much you'll be getting? You'll be getting around 3, right? You'll be getting around what it is 1.8 divided by 0.03. 0.03 mole, right? So number of moles of oxygen, so 0.03 moles only you'll be getting, mole, right? Okay, now here given mass we have to identify. So mass equal to, I did not mention given mass because here mass only they are asking. So mass equal to number of moles into molecular mass, molecular mass. So number of moles, how much? 0.03 into molecular mass, how much it is? 32, oxygen 32, right? So gram per mole. So here, what is the answer? You'll be getting around 0.956 gram. Here, this mole we cancel. No, so this is mole. 0.03 mole, right? Mole. So this mole cancel. So that is actually 0.956 gram. That is a given mass of oxygen. So mass equal to here approximately. Here we can bring 0.956. No, 6. No, we can bring it here 6. 5 converted to 6. Okay, so the option. So here gram 0.96 gram. I hope you got the clarity. 0.96 gram. So which is the correct option? 0.960. Yeah. So option B is the correct option. Hope you got the clarity. Yeah, come on, let's go to the next question. The number of oxygen atom in 4.4 gram of carbon dioxide. Yeah, come on, let us check. So here gram, given mass they have provided. So number of moles. So number of moles of carbon dioxide. So here what it is, 4.4 gram of carbon dioxide divided by molecular mass 44 gram per mole. So what you will get it? You will get the answer 0.1 mole, right? So 0.1 mole. So how many oxygens are generally available in this point? 2 oxygen. So number of oxygen. So here oxygen atom only they are mentioning. No, so number of oxygen atom. Oh, I just mentioned in the words that oxygen atom, right? Because that is the atomic molecule, right? So number of oxygen atom in carbon dioxide. In carbon dioxide, here actually CO2, right? So CO2 means here 2 only, right? So this is 2 oxygen atoms are available right now. In the number of molecules in 1 mole of carbon dioxide, number of molecules in 1 mole of carbon dioxide, that is 6.023 into 10 to the power of 23, right? Molecules, right? 1 mole of, that is molecule only, molecule, right? Okay, now in that, therefore this is for number of molecules in 1 mole of carbon. So that's what we, how much we got it? 0.1 only we got it. Now here what is the answer? 0.1 only. No, so 0.1 mole, 1 mole of carbon dioxide. Number of mole, 1 mole of carbon dioxide, this much. That means 0.1 mole of carbon dioxide. How much it will be there? Do you think? So 6.023 into 10 to the power of 22, right? This is 23, right? Now in this point 0.1, no, so that is 22 only. So one thing it will be reduced, right? Now we have to check what it is. Number of oxygen. So number of oxygen atom in carbon dioxide in 0.1 mole. 0.1 mole. So here simple, here 6.023 into 10 to the power of 22 into 2 atoms, right? So altogether you will get what it is, 6 2s are 12. So 1.2 into 10 to the power of 23. Here 22, no, 23. Here 22, no, here 23. How do we get 22 here? 23, just we are 2 into, 6 12, no, so just we bring it that point over here. So here molecule, oxygen atom, right? Molecule. Right now, what is the option they have given? 1.2 into 10 to the power of 23. What they are asking question. In that question, it will be easy to understand. Right. So this is number of oxygen atoms only. So here 1.2 into 10 to the power of 23 atoms in 4.4 gram of carbon dioxide. Atoms they are asking, no. So we just bring atoms only. 1.2 into 10 to the power of 23. Option D is the correct option. So the answer it is atoms. That is only we mentioned here now, right? Number of oxygen atoms in carbon dioxide. So this is atoms. Right? Hope you got the clarity. How do we bring it all these points? Come on, let's go to the next question. An organic compound contains carbon, hydrogen, nitrogen. They have given carbon 40%, hydrogen 13.33%, nitrogen 46.67%. It's empirical formula. This is very simple. Come on, let us identify easy way. This is element. You just take that way, columns, element and percentage composition and atomic mass and percentage ratio, right? Percentage ratio, right? Least to whole number ratio and empirical formula, right? Okay, now let us write the data here. Element, what is the point they have given? Carbon, hydrogen, carbon, hydrogen, and nitrogen. These are the three they have given. Now, percentage, how much they have given? 40 percentage and 13.33 percentage, 13.33 percentage, and 46.6 percentage. And atomic mass, let us identify. So atomic mass, actually here what it is, carbon atomic mass 12, and hydrogen atomic mass 1, and nitrogen atomic mass what it is, 14. Now percentage, how do we identify percentage? What it is, given mass by molecular mass or atomic mass, right? So given mass it is 40 percentage, right? So 40 divided by 12, so how much it is actually 3.33 percentage, right? Now in that way it is actually 13.33 divided by 1, so you will get what it is, 13.33 only you'll be getting, right? Now here 14, so 14 divided by 46, right? 46.6 divided by 14, so how much you will get? 3.3, right? So 3.33, right? So you will get least whole number ratio. Which is the least? So this is this one as well as this one, both are similar, so that only we can bring it. So which is the least number? 3.33 divided by 3.33, so you will get 1. And the same way here, what it is, 13.33 divided by 3.33, so you will get around what it is, 4 you will be getting. And the same way here, 3.33 divided by 3.33, so you'll get 1. So here empirical formula you got it, carbon, hydrogen, and nitrogen, everything what it is, here 1, here 4, here 1, so 1 4 1, so 1 4 1, no, so CH4N. So empirical formula only they are asking, they are not asking molecular formula, empirical formula. So molecular formula, if they are asking N equal to molecular formula by empirical formula, in that way empirical mass you can identify. So here at actually CH4N, option B is the correct option. I hope you got the clarity. How do we identify? Very easily. So you just, instead of going for all around, directly you can bring that columns, elements, percentage, atomic mass, percentage ratio, least whole number ratio, and then empirical formula. Hope you got the clarity. How do we identify? Come on, let's go to the next question. And select the wrong chemical reaction among the following. See, ammonia plus chlorine, you will get ammonium chloride and nitrogen. Yes, it is correct equation. And balancing also, it's correct only. Yes, it's balancing correct. And the same way, calcium hydroxide plus chlorine, you will get calcium oxychloride, that is bleaching powder, plus CaCl2 plus H2O. Yes, this is also correct. And 2NaOH plus Cl2, 2NaCl plus H2 plus O2. Yeah, NaOH will not react with the chlorine directly, actually. They did not mention any condition also. If they have mentioned condition, at least with the cold NaOH, yeah, I just bring that idea for you here. This is actually wrong. Sodium hydroxide will not react directly with the chlorine. There will be some condition with the cold, with the hot, like, right? So I just mentioned with cold, with cold, NaOH, actually directly it will not react. With cold it may react, then also you will not get what it is, H2 and O2, that is oxygen, hydrogen, you will not get. So here actually NaOH plus Cl2, you will get NaCl plus NaClO plus H2O. This is only you will get when it is in cold condition. So here 2 you will get, because here 2, right? 2 Na, 2 Na. So you will get 2 over here. Actually, with cold condition, this is. Suppose if it is hot condition, with hot condition, right? So here the same, NaOH plus Cl2, you will get what it is, NaCl plus NaClO3 plus H2O. So this is also balancing equation here, actually. Cl2, Cl3 it is there, no? So here actually 3 ClO, right? So that means here also we just 6. So that means here 3 chlorine to balance only we are going to put. So here 3, and here oxygen, how much? Oxygen also 3, and here water molecules also 3, right? So oxygen 6, yeah, 3 oxygen, here 3 oxygen, 6, yes, got it, 6 oxygen. And sodium it is 3 6, right? So here 3 it is there, 6 Na, right? Here, so here 3 oxygen plus here 3 oxygen, 6 oxygen. And hydrogen, here 6 hydrogen, 3 2s are 6 hydrogen. And chlorine, it is 6 chlorine, here 3, and plus here 3, yes, 6 chlorine. Yes, it's balanced. So with the hot condition, you will get oxychlorate, what it is, NaClO3. With that cold condition, NaClO. Now you see the difference. Actually, sodium hydroxide with chlorine, Cl2 directly it will not react with the sodium hydroxide. And NaOH to produce hydrogen oxygen in cold condition, it is not possible. So actually H2O2 will not give. So which is the wrong option? Come on, last option, let us check. MnO2 plus 4 HCl, it gives MnCl2 plus Cl2 plus 2 H2O. Yeah, balancing equation. Yeah, for hydrogen, chlorine, how much? For chlorine and oxygen, O2, right? MnO2, MnCl2, 2O2. Yes, it's correct. Yes, all these three are correct. Which is the wrong only they are asking now. So option C is the wrong. With hot condition, with cold condition, what are the products you just check it? But actually what they are giving, NaCl plus H2 and O2. So actually water molecule only it has provided, H2O2 will not provide. So completely it's wrong option. I hope you got the clarity. Come on, let's go to the next question. Removed from 98 milligram of H2SO4. Then the number of moles of H2SO4 left are. Okay, see, they are removing that 98 milligram of H2SO4. Actually, how much they have removed? 3.01 into 10 to the power of 20 molecules have removed. So 1 mole actually what it is? 1 mole of H2O. 1 mole of H2O, how much it will be there? 1 mole of H2SO4 has 6.023 into 10 to the power of 23 molecules will be there. Right. Okay. Now here 3.01 into 10 to the power of 20 molecules are removed from 98 milligram of H2SO4. So 98 milligram of H2SO4 means milligram 1 into 10 to the power of minus 3. Can we bring it in this point also? Here last at last. Okay, now here removed molecules, how much number of molecules removed? So number of molecules, data here, molecules removed equal to 3.01 into 10 to the power of 20 molecules have removed, right? Molecules. So that means removed by per molecule, right? So that means here how much left they are asking now. So 0 point here actually what it is 3.01 into 10 to the power of 20 molecules divided by 6.023 into 10 to the power of 23. So you will get around what it is 5 6 5 are 30, right? So 0.5 0.5 mole you will be getting. Okay, now here what we should add here actually 10 to the power of minus 3. Why? Because it is milligram they are asking. No, so the number of moles of 98 milligram of H2SO4. How much it is? 0.5 into 10 to the power of minus 3 left. That is actually what is 0.5 into 10 to the power of 3 mole. That is actually right. Mole. See, number of moles only they are asking, right? So mole. Right. I hope you got the clarity. Come on. What is the answer? 0.5 into 10 to the power of minus 3. Yes, minus 3 mole. Right. I got that. So which is the correct option? Option C is the correct option. Yes. Come on. Let's go to the next question. Chloride precipitate when a solution containing 11.70 gram of sodium chloride is added to a solution containing 3.4 gram of silver nitrate. This is very simple only. Right, come on, let us write the equation so that we'll get the clarity. Here in this, here mass of silver chloride, it is a product. Okay, silver nitrate AgNO3 plus NaCl. We get AgCl plus NaNO3, right? NaNO3. This is a equation. Now in that here sodium chloride 11.70 gram and here added to the solution containing 3.4 gram silver nitrate. So what is the percentage of, what is the mass of silver chloride? That is the question. So let us go and identify that number of moles. Given mass they have given, no? So number of moles let us identify. So number of moles, how to identify? So number of moles of AgNO3 silver nitrate. Okay, so here given mass 3.4 divided gram, given mass by molecular mass what it is here AgNO3. So this is 108 plus 14 plus 16 into 3. Here 16 into 3 48, right? So altogether it is 170, right? 170 gram per mole, right? So 0.02 mole, right? So when you calculate, so the data mole, it is 0.02 mole, right? Data is easily we can identify. Okay, now the same way number of moles of sodium chloride, number of moles of sodium chloride, NaCl, right? NaCl, you will get what it is given mass 11.70 gram divided by molecular mass, how much it is 58.5. Sodium it is 23 plus 35.5, yeah, gram per mole. So here you will get number of moles 0.02 mole. Here also, so mole ratio it is same 1:1. So here also 0.02 mole. So here mole ratio it is 1:1. So the mass of silver chloride only we have to identify. So to find the mass of silver chloride precipitate, mass of silver chloride PPT, how much it is? So number of moles. So number of moles into molecular mass. See here actually mole ratio, how much it is? 1:1. Even balancing equation also, stoichiometric coefficient. So even here also 1:1 only. See, here also 1 and here also 1, balancing bond balanced equation, right? So it will be easy for us to calculate the same kind of question. Actually, values vary, but that same concept only. So here actually 0.02 into molecular mass of AgCl, it is 143. So gram per mole. So what is the answer you will get? Actually here, here mole, this is mole, no, number of moles, this is mole. So this mole and this mole cancel. Mass only, no, given mass. So here actually what it is, given mass equal to number of moles into molecular mass. So molecular mass of silver chloride, it is 143 only. Just check it, 143 only. So here what you will get it, you will get around 2.866 you will be getting, right? Gram, this is, so 2.866 we just change into 7, right? So given mass of silver chloride precipitate, so mass of AgClPPT precipitate 2.87 gram, right? I hope you got the clarity. Now come on, let us check the option which is the correct option. Yeah. Yeah, option C is the correct option. 2.87 is the correct option. I hope you got the clarity. Same question, values are vary in J mains. Come on, let's go to the next question. F6 is treated with 1.8 gram of water. The product obtained is, see, let us write the data here. Here, actually, EXEF6 xenon hexafluoride combined with water. So, what is the product? So, indirectly, they have given that 0.1 mole of xenon hexafluoride combined with 1.8 gram of water. So, one thing they have given the mole, the other thing they have given mass. So, given mass means the number of moles equal to given mass by molecular mass. So, number of moles we have to identify. Mole they have provided here. Here we have to identify the number of moles. So, for given mass by molecular mass, no, the formula. So, 1.8 divided by molecular mass of water, here 18 gram per mole. So that means here gram per mole. So mole, gram cancel. So that means here 0.1 mole only you'll be getting. So here also 0.1 mole only, right? So here also 0.1 mole, here also 0.1 mole. So the numbers will not be changing. That means here we no need to change any balancing. So directly, so what is the answer you will be getting? Here XeOF4 plus HF, right? So HF means what it is? H2. So here 2 HF. So that means XeOF4 plus 2 HF. Is it balanced? 6 fluorine here, 4 plus 2 6, hydrogen 2, oxygen 1, F6, xenon 1. Yes. So what is the answer? XeOF4. So option C is the correct option. C. How indirectly, very intelligent question. Come on. Yeah, I hope you got the clarity. Come on, let's go to the next question. 1 gram of magnesium is burnt with 0.28 gram of oxygen in a closed vessel. Which reactant is left in excess and how much? See, the same question we have gone through in another one more video, JE mains also, but values are vary, right? Come on, but same concept. All right, let us write the equation. Here actually Mg plus O, right? So Mg plus O2, right? You will get 2 MgO. So here 2 MgO, because here 2, here 2. So 2 MgO. This is the balanced equation. Now, in that data, let us write 1 gram of magnesium burnt with that, what it is, 0.28 gram of oxygen in a closed vessel. Which reactant is left in excess? A limiting reagent. Indirectly, they are asking limiting reagent. Okay, number of moles. Given mass, they have given no. So, number of moles of magnesium Mg equal to 1 by 24. Magnesium gram per mole. Atomic mass of magnesium is gram per mole. So 1 by 24. So this is 1 gram. So what is the answer you'll get? So 0.0412 mole. So please remember all this, because finally we'll conclude the answer for that. Okay, now next one, oxygen. Number of moles of oxygen. So number of moles of oxygen, right? O2. So you will get what it is here, 0.28 gram, right? So the data they have provided now. So divided by 32. So gram per mole, right? So this gram and gram will be cancelled. So the answer will be 0.00. Yeah, you'll get 0.0875 mole. Right. Okay. Now balancing ratio, let us check. Here balancing ratio, it is actually what it is. 2:1, right? So 2 moles of magnesium, 1 mole of oxygen, right? So balancing ratio 2:1. So the moles of magnesium required, is 0.0085. Then only we can identify what it is, limiting reagent. So 0.00875, right? 875 into actually this is oxygen moles, right? This is oxygen moles, number of moles of oxygen into this is balancing ratio 2 by 1. So answer, how much you will be getting? 0.0175 moles. There's actually number of moles of magnesium required. Actually, how much number of moles of magnesium is available? 0.01251 yeah, mole. 0.012 0.0412 mole is available, sorry. But actually how much it is required is 0.0175 it is required to react to this of magnesium. It's required. Okay, now yeah, I just mentioned here clearly. Actually what it is, 0.0412 mole of magnesium is available, but taken moles available, but taken moles taken for reaction, right? In that way we can write it. Taken for reaction, magnesium as 0.0175 mole. See, how do we get it? It is for balancing mole ratio 2 by 1. That is the way. This is magnesium and this is oxygen, right? That is the way we have taken, right? I hope you got the clarity. Yes. Okay, now which is excess and which is limiting reagent? So here 0.0412 mole of magnesium. So this is in how much it has taken? 0. What it is, 0.175 it has taken. Oxygen, how much it is? Oxygen, it is around 0.00875. So this is oxygen moles. So oxygen only is the limiting reagent. This is for oxygen moles also we can compare that 0.00875 mole of oxygen. Magnesium 0.0175 remaining it is there. So that means magnesium is excess. Magnesium is excess. That is what they are asking. Which reactant is excess? How much it has left? Okay, magnesium is excess. Oxygen, it is limiting reagent. Limiting reagent. Right. Okay. So limiting reagent we found. Now how much excess? That means how much gram left they are asking. Okay. So mass of magnesium reacted. Okay. Mass of magnesium. Mass of magnesium reacted. Mass of magnesium reacted, that is a given mass, right? So given mass, what is the formula? Generally we use it is moles into molecular mass or moles into atomic mass. So moles, how much we are getting in that into atomic mass here. So here actually what it is, given mass only we can provide. So moles into atomic mass. So it is atomic mass of magnesium, it is 24 moles. How much it is? 0.0175, right? 0.0175 moles of magnesium, please note down, into atomic mass 24. So when you calculate this, how much you will get? You will get around 0.425 gram. Right. So mass of magnesium, initially how much it has taken? 1 gram of magnesium only we have taken. No? So 1 gram of magnesium minus how much it has reacted? 0.425 gram it has reacted. So 1 minus 0.425 gram. So altogether, when you're calculating this, you will get around 0.575 gram. So 0.575 gram. Okay. So excess it is magnesium and how much it is? 0.575 gram left. Okay, now what is the question? And they are asking which is excess, which reactant it is excess, and how much it is excess. The reactant excess, it is magnesium only excess. Right, how much it is excess? It is 0.575 gram excess magnesium. Right, 0.575 here, option A, B, C, D. Yeah, B option you see 0.58. See, this is 5 now, 5 and above it is converted into 1. So that means here 0.58, can we bring it? Yes. Okay, so option excess it is magnesium and 0.58. Option B is the correct option. Hope you got the clarity. Yeah, we have seen all these questions. Hope you got the clear idea about this concept and these questions. And in our next question, in our next video, we are going to see that is a redox reaction PYQ. And thank you for your great support and thanks for watching. Generally, some basic concepts of questions and all leads to that redox reaction, because oxidation, reduction, oxidizing agent, reducing agent, these also will be included. Normality also in between, equivalent mass, those points and all will be coming. So that is our next topic, next session. We are going to see redox reaction. And thanks for your great support. Thank you for watching.